Here we go. Okay, so I'm going to draw a right triangle, and you know that if this is little a and this is little b and this is little c, the Pythagorean theorem a squared plus b squared equals c squared. And in terms of values for a, b, and c, in standardized tests, they tend to use Pythagorean triples. And these are the numbers that are nice. So for example, 3 squared plus 4 squared equals 5 squared. You've seen that before. 9 plus 16 equals 25. The other ones, there's many that you might see, like 5, 12, 13. Hopefully you've seen some of these before. Do you remember any other triples? Now that I'm sort of asking you to maybe think back to something you saw in class. It's okay if you don't, but
yeah, I don't really remember.
so there's an infinite number of these, but in terms of like the ones that you want to know, this is a pretty good list right here. Here's another one that we might use. So they're not going to ask you to like solve for a side of a triangle, most likely. They will, but it'll be a nice number. Like they're not looking for you to actually use the Pythagorean theorem. Now, what most students don't realize, and this is where you can build some speed on the standardized test here. So I'm going to grab these, and the way the triples work is you can also let me just move this down. You can also multiply these by, say, like 2. Okay, so if you multiply each of these by 2, 6, 8, 10, 10, 24, 26, 16, 30, 34, 14, 48, 50. So notice how the numbers gets pretty big. You probably wouldn't see that, but you should keep in mind that you can just multiply this sort of base case to get other ones. So the ones you'll commonly see would be these here, like the 3, 4, 5, the 5, 12, 13, 8, 15, 17. Those are more common here. And the faster you're able to recognize this, and really there's no shortcut here. You just look at the numbers and kind of see how they work together. You will save time on your standardized test. So this goes on forever, okay? But so just keep that in mind. So here's the kind of problem that I was thinking about for us to start with today. Oh, and actually, let me draw a triangle here. We should do a little more review on this. So let's say this is 3, 4, 5. This is A. We need to remember what sine of A, cosine of A, and tangent of A is. So sine is opposite over hypotenuse, so 4/5, and it's relative to this angle down here. Cosine of A is the adjacent over the hypotenuse, so that's 3/5, and then tangent of A is opposite over adjacent, so 4/3. Now there's 3 other trig functions that you might see. There's cosecant, which is the reciprocal of sine. There's secant, which is the reciprocal of cosine, so it's the flip of it. And then there's cotangent, which is the reciprocal of tangent. This would have been covered in geometry, maybe again in algebra 2, not sure. Does this look familiar to you?
Yeah, a little bit.
A little bit. Okay, we'll go through it slowly here. So here's the type of problem you might see. It'll say if secant A equals 5/3. Okay, so you would want to draw a triangle and label one of the angles here. We'll call that one A. And secant's not one of the well-known ones, so you'd have to say, oh, what is secant? Well, secant is really, actually, it's the reciprocal of cosine. Or more probably what the way most students I think about this is it's one over secant is cosine. These are exactly the same. They're just written slightly differently. Just like I showed you up here, let me scroll back up here. If cosine is 3/5, secant is 5/3, you just flip it. So cosine is 1 over 5/3. We talked about fraction stuff, so that's 3/5. So cosine is 3/5. So when you look at this triangle here, hey Julia, so what we're doing here is solving for cosine because secant's not one of those well-known ones. So cosine of A is the adjacent leg over the hypotenuse. What is the other leg here? And it's a Pythagorean triple, so I'm hoping you'll just be able to tell me from what we've done previously.
Is it 4?
It's 4, right? You don't want to use the Pythagorean theorem because it's slow. You want to recognize this. Okay, very good. All right. Now, so just to see how you're doing here, here's B. Okay, here's B. I want you to tell me what the sine of B is. Okay. And remember, sine is opposite over hypotenuse. Can you tell me what the sine of B is in this problem?
Is it 4 over 5?
So the opposite of B is this 3. 3 is opposite of B.
Oh,
And the hypotenuse is always the one that's opposite the 90 or the longest side, so 3/5. How about the cosine of B? That's the adjacent over hypotenuse. You got to go to wherever B is, and then the adjacent over the hypotenuse. What would that be?
adjacent. Oh, that would be 4/5.
4/5. Very good. Okay, and how about the tangent of B? Now I have to go back up and get the triangle here. So the tangent of B, tangent is opposite over adjacent.
Um, 3/4.
3/4. Very good. Okay, now this should go a little faster. Cosecant of B, cosecant is the reciprocal of sine, or the flip of this. So that's 5/3. The cosine of B goes with the secant of B. The secant of B is the reciprocal of cosine, so that's 5/4. We actually already, that was given in the original problem. Cotangent of B is the reciprocal of this, which is 4/3.
Okay.
All right, so let's do another one here. We're gonna do another triangle problem. Okay, so let's say the cotangent of B is 12/5. Cotangent of B is 12/5. So you have to say, well, I don't really know what cotangent is, but I know that tangent is 1 over cotangent, or the flip of cotangent. That's what this means. It means literally means the flip. So that's 5 over 12. You draw your right triangle, label that B. It can be either one. Like this could be B, that could be A. It doesn't really matter.
Okay.
But tangent, you have to remember, okay, tangent is what over what? It's opposite over hypotenuse. So where does the 5 go? Where does the 12 go? Hopefully, I'm sorry, I've got this wrong. It's opposite over adjacent. Think about something else. So the opposite is 5. The adjacent is 12. You always want to find the hypotenuse here. What is the hypotenuse in this case?
13.
13, good. Okay.
Okay.
So now now we can find all of the things that we want: sine B, cosine B, and tangent of B. So go ahead and see if you can find those three for me, please. Hey, Julia, you're back. Do you have the answers for sine, cosine, and tangent for me?
Yes.
All right. Let me know when you got them. Tell me what sine is, please.
Sine is 5/13.
Okay, very good. How about cosine?
12/13.
Good. And tangent, we already know, is 5/12. So how about cosecant of B? Secant of B and cotangent of B. Do you have some answers for me on these, Julia?
Is cotangent B 5/12?
It's the flip of this. These are
Oh,
all three of these are reciprocals of the ones on the left. And that's the whole point here
oh, okay.
is there's nothing more. You don't have to like relearn the rules or you just flip them. There's a nice patterning here for them, but you have to know that sine goes with cosecant, cosine goes with secant, tangent goes with cotangent.
Okay.
All right, is that okay?
Yeah.
Okay. So let's do another one here. Let's say that what have we not done yet? So let's say cosecant of A equals 17/15. Okay. So I want you to tell me, which one does cosecant go with? Is it, which of the other trig functions is it the reciprocal of?
Cosecant would be cosine.
Cosecant goes with sine.
Oh, with sine.
Yeah.
Okay.
And cosine goes with secant. There's some lettering there. So that means that I'm sorry, the sine of A is 15 over 17. Okay, so that's opposite over hypotenuse. What is the other side here from our list of triples?
8.
8. Very good. Okay. So I want you to give me cosine A, tangent A. We already have cosecant A, secant A, and then cotangent A. I want you to come up with all 6 of those, and then we'll come up with we'll do some more problems. How are you doing on this, Julia?
I think I'm good.
Okay, so here are the correct answers. There's cosine, and then I like to just flip them immediately to get the other ones. Tangent is 15 over 8, so cotangent is 8 over 15. Okay, so why are we doing all this? And that's, that's kind of the question that you might have, because this is the style of the question that you might see on a standardized prep thing. So it might say if, and we've kind of already done this, if secant A equals 5/4, what is 1 plus sine A over 1 minus cosine A? Hey, Julia, so here's the question. If secant of A equals 5/4, what is 1 plus sine A over 1 minus cosine A? So to do this type of question, you have to draw the triangle like we've been doing.
Okay.
Here's A, but I'm giving you secant, and secant's not good for drawing triangles. You want cosine, because cosine is the reciprocal of secant. So what is the reciprocal of this?
4/5.
4/5. Cosine is the adjacent over the hypotenuse. What is this other side here?
3.
3. Okay. So now what is sine A? What is sine A? Sine A is
Sine A is 3/5.
3/5. Okay. And then cosine A we just found. Okay. So a little bit of like synthesis, you got to figure out the triangle, and then you got to use the triangle to find these other things, but you're not done. Okay. So now when you see this one, you want to think of it as 5/5. When you see this one down here and there's a fraction of 5/5 minus 4/5. You see where I'm going with this? So you're going to add the numerator, 8/5. You're going to add or subtract in the denominator. Okay. Now I don't remember if we covered this because this doesn't happen all that often, but when the two bottoms are the same, you just write the top numbers. So this becomes 8 over 1.
Okay.
Any questions on that or anything you feel like didn't understand? Because we're going to do one pretty much like it again here.
I don't have any questions.
Okay, so let's do one that's really similar here. Let's go if cosecant B equals 5/3, what is 1 minus sine A over 1 plus cosine? I'm sorry, B this time, B. Okay, so the first thing I want you to do is try drawing the triangle and let me know when you have that, and then I'll check that for you before moving on to the next part.
Okay. So are we supposed to find sine B and cosine B?
Well,
Is that what you're asking?
I just wanted you to draw the triangle first, so that I could
Oh,
check
okay.
that. Where did you put B? Did you put B down here or at the top? It doesn't matter. Just wondering which way you did.
I put it at the bottom.
The bottom here. Okay. So cosecant is the reciprocal of sine. So sine B is 3/5, and that's 3 over 5, and then a 4 down here. Is that what you got?
I had the 3 and 4 flipped.
Okay. So that's you got to be careful there. Sine is opposite over hypotenuse. 3 is obviously opposite. 4 is the adjacent. Okay. So now you've got to fill in the blanks on sine B and cosine B. So sine B is 3/5. What is cosine B?
Cosine B is 4/5.
4/5. Okay. So see if you can reduce this from here, please.
Um, 2/9.
Okay, so let me check here. So this is 2/5 over 9/5. Yeah, it's 2/9. Perfect. Okay, so let's increase the difficulty just a tiny bit here. Let's give you a new triangle here. So we'll go if tangent A equals, let's go 15/8. What is 1 plus cotangent of A over 3? So try drawing the triangle. Let me know when you've got that down, and then we'll compare and see if we're together on it. If we got the same.
Okay.
Got the same lengths.
Okay, I think I might have it.
Okay, so did you put A down here or at the top?
At the bottom.
All right, so tangent is opposite over adjacent, and then the hypotenuse is 17. Is that what you have?
No.
Okay, so I'm hearing a bit of like, these are the mistakes can't have early on in these problems. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And I like, I really, to me, this is opposite. The word adjacent means next to. You could argue that 17 is next to, but because it's the longest side, it's given the designator of hypotenuse rather than adjacent. So, but it depends where you are. If you're up here at B, adjacent is now 15, and opposite is now 8.
Okay.
So somehow we gotta like get that really down, because it's gonna, every problem will be missed as a result of that. Okay, so with this triangle here, cotangent of A, well, you actually didn't have to draw the triangle. I wanted you though, because I wanted, this is an important part of it for other problems we'll do. Cotangent is the reciprocal of tangent. So that is 8/15.
Oh, so when it's cotangent, then you flip it?
Yes,
Oh,
there's
okay.
sine is the reciprocal of cosecant. Reciprocal, we'll say.
Okay,
Okay.
that's where I got confused.
Cosine is the reciprocal of secant. Tangent and cotangents are reciprocals, and these are just time-saving things. I mean, they really do help. I know it's more stuff to remember, but it gets better. I mean, you do this a few times, you're like, oh yeah, that makes sense. Okay, so back to our problem here. Our problem is 1 plus cotangent of A, so 1 plus 8/15 over 3. Go ahead and simplify that, please.
Um, okay, I got 23/5.
Okay, so the 1 becomes 15 over 15 plus 8 over 15 all over 3. So the numerator is 23 over 15. Okay. This was another case we looked at. When you divide by 3, you can either move it to the bottom or multiply by 1/3. It's better just to move it to the bottom. So that gives you 23 over 45.
Oh, okay, that's what I got originally.
Okay, good. So let's try another one here. The goal here is just to keep working through these, getting our understanding. So let's go sine B equals, let's go 4/5. So we want to find out what is 1 plus tangent B over 1 minus cotangent B. Okay. So start by drawing the triangle. And again, just let me know when you get that down so that we can compare notes here and see if we got the same thing.
Okay. Okay.
Okay, so if you put B down here, sine is opposite over hypotenuse, and then the other leg would be 3. Is that what you have?
Yes.
Great. So what is tangent of B?
Four thirds.
Agreed. And then what about cotangent of B?
Um, 5/4.
Cotangent is the reciprocal of tangent.
Oh, of tangent. 3/4.
3/4. Okay, so now you have enough to answer this question. 1 plus 4/3 over 1 minus 3/4. So go ahead and give that a try to see if you can simplify it. It's definitely doable. So let me know when you've got an answer, please.
I got 7/3 over 1/4, but I don't remember how to reduce it.
Okay, so that
Correct.
is correct. 7/3 over 1/4. So when you're dividing by a fraction, you multiply by the reciprocal. So
Oh,
multiply
yes.
by
Okay.
4 over 1, and that gives you 28 over 3.
Okay.
Okay, is that good? Is that clear?
Yeah.
Okay, so let's do another one here. Let's say secant of A equals 5/4. What is, let's go cosine A. This time though, we're going to go 1 minus sine squared A. Okay, so just to be a little extra step there in that last part, we're going to end up squaring it, but you can totally do this. So go ahead and draw your triangle, and yeah, let's start there, and then tell me what cosine A is and sine A is when you're all done, please. Do you have some answers for cosine A and sine A?
For cosine A, I got 4/5.
Okay, agreed. How about sine A?
3/5.
Yes. Okay, so the way this works is you put the value of cosine A in the numerator. Sine squared A, you're going to square sine of A. So as a reminder, you square the numerator and then the denominator.
Okay,
Okay,
so
and then see if you can simplify it from there, please.
um 5/4.
Okay, so you think the answer is 5/4. I'll just circle it here. So in the bottom, it becomes 25 over 25 minus 9 over 25, 4/5. So the numerator stays 4/5, and the denominator is now 6 over 25. And then you multiply by the reciprocal. So you take that 4/5 and you multiply by 25 over 6. Those cancel. 2 and 3, I get 10/3. Do you see your mistake where you went off on that? Because you said 5/4, right?
Yeah.
Oh, I'm sorry. 16. There's the mistake. It's 16. So what
Oh,
does that do? What does that do? That changes this to let's go 1 and 4. Yes, it is 5/4. Very good. I
okay.
was like, huh, where is it? Excellent. Okay, so let's try another one here. Let's go cotangent B equals 15 over 8. Let's go 1 minus sine A over cosine A minus 1. So see if you can work this all the way through. This may be our last problem. Take a few minutes and see what you come up with, and ask me any questions you have along the way.
Okay. What do you do to find the
Oh,
other value?
I put the wrong. Let's go with B's. I'm sorry. Those are meant to be B's. Apologize. That does matter significantly. So it's a good thing you asked about that. Okay, so this is what your triangle should look like. And then sine B would be 8/17 and cosine B would be 15/17. Is that what you have?
Yes.
Fantastic. So it's 17/17 minus 8/17, which is 9/17. And then it's 15/17 minus 17/17 minus 2/17. And the 17s cancel and you get minus 9/2 when you're all done.
Okay.
So I haven't said in a while, but if you have time, it would be great to actually redo all the problems we did at some point. Like you can watch the video and then just pause the video and try to work it out. And seeing it again will help with that. So good job today. We'll do we got some stuff next week on the schedule, and I'll see you next time, I guess.
Okay. Sounds good. Thank you.
You're welcome. Bye now.
Bye.